Okay, so what is correlation? In statistics, correlation is a measure of the direction and strength of the linear relationship between two quantitative variables. So let's say we have a scatter plot and our two quantitative variables is x and y. Then we can observe the relationship between the two. We can see that in that case it would be linear, and then we can calculate from the data the value of the correlation coefficient r, and it will be a number between -1 and +1. So the closer the value is to +1 or -1, it means that the points on the scatter are lying close to a straight line. And the further away they are from a straight line, so let's say we have points that are out here, then we would be, r then would be calculated closer to 0. So let's look at some examples. So here we have r is equal to +1, and a very rare event. Your data probably would not have that, but if they were lying perfectly along a straight line, you would calculate r to be +1. Notice in the second plot, if there's some points above the line and below a line, you have to imagine the line, then r would be still positive because we have a positive slope, but it would be a number between 0 and +1. Moving on to a negative slope, so here's some scatter plots that have negative slope. If they are lying along a perfect line, r would then be calculated as -1. And if there's some scatter, so just imagine a line, r then would be a number between -1 and 0. And so if r was equal to 0, your plot would look something like this. So you would have x and y, and let's say we have no slope. So you can just imagine a line going that way. In this case, r then would equal 0 because there's no relationship between the two variables. So more examples here. We can see in the first scatter plot, we have a strong linear relationship between x and y, and we have r has been calculated as 0.843. In the second plot, you can see that the points are further away from an imaginary line, and so we would then have a weak r at, in this case, it's 0.189. And here we have negative slope. You can see a strong linear relationship between x and y. R is calculated at -0.906. And here we have points that are further from that line. And we would have a weak linear relationship between x and y. And R would be -0.368. So in the upcoming slides, we're going to learn how to calculate R. But here's some properties. The correlation R makes no distinction between the variables. So if you were to swap basically the x and y variable, you would still get the same value for R. Correlation is unitless measure, and it does not change if we change the unit. So if you were to transpose your data from, let's say, centimeters to meters, the value of R will not change. It will remain the same. And that's for either or both variables. Correlation R only describes linear relationships. You can calculate R for curved relationships or nonlinear relationships, but it is not valid. So you want to remember it does not describe curved relationships or nonlinear relationships. And the correlation R is not a resistant measure, means it's very influenced by even just a few outlying observations. So we'll look at an example here. In the first plot, we have R equals 0.342, so it's weak relationship between x and y. And if we go from this plot to this plot, the only difference is 1 point, and it's definitely an outlier in the X direction, we can see. And look at how R has changed. It has increased from 0.342 to 0.753 just by adding that 1 point. So the correlation R is influenced by outlying measures. And so we will learn how to calculate R in the upcoming slides.